All right, so we're going to go through one example of finding all the zeros of a polynomial. And so it could look sort of like this. And so first thing is we want to think about how many we're expecting. And so an x to the fourth polynomial, if I get it factored completely, should have 4 factors. So I'm expecting 4 zeros. Now we've done some problems like this where we were able to get started factoring by taking an x out of everything and sort of reducing the power. Unfortunately, there's a plain 39 here at the end. We cannot factor out an x, so we need something else to get us started. And typically what that's going to do is, the way we're going to get started is by looking at the graph. So I've got this equation entered in my calculator already. I do zoom standard, and of course I know zeros are like x-intercepts. And so when I look at this graph, it appears that there's one at -3, and then also something between 0 and 1. And I could use my calculator to get a better idea of that. I'm also going to show you a tool that is sort of handy to go along with your calculator, and it's called the rational root theorem. And so the way the rational root theorem works is I'm going to make a list of what are called P's and Q's. And so P is going to be the factors of the constant. And so that's the number with no x's on it. And the Q will be the factors of the lead coefficient. And so that's the number in front of the highest power of x. And so in this case, the lead coefficient is pretty easy. It's 2, and so there are only 2 factors. Don't forget the 1. 2 is a factor also, of course. 39, not too big of a list. Basically 3 and 13 go into it, and then of course 1 and 39. And then I'm going to make fractions, and I'm going to make fractions of the form P over Q. So I want all the P's on top over all the Q's on the bottom. And so I'm just going to sort of go through my list here. So P on top, so I could have 1 over 1, 3 over 1, 13 over 1, 39 over 1. Of course, I don't really need to be writing the ones on the denominator. And then I do all of them over 2. And so I could have 1 over 2, 3 over 2, 13 over 2, and 39 over 2. And then all of these can be positive or negative. And so any of the negative numbers go in also, and so these could all be positive or negative. And so this is a long list. I wouldn't want to have to check them all, but if there is a rational root, if there's a zero, if there's a number that's a 0, that's a nice rational number, it will be on this list. And so now when I go to this list and I go to my graph, oh, I know there's one at -3. Well, that's good. -3 is on my list. And between 0 and 1, well, there's only one number on this entire list that's between positive 0 and positive 1, and that's 1/2. So I think I know my 2 solutions. And so now the way I'm going to check and make it official and find the missing 2, because I am expecting 4, is I'm going to use my division. So I'm going to use synthetic division. Some of you might like polydoku. I'm going to write, so let's just zoom out here for a second. I'm going to write my coefficients down. So 2, -7, -7, 83, and -39. And then out in front, I put the number that I think is a 0. And so I thought -3 was a 0, which means I think x plus 3 is a factor. And so now I'm going to divide out -3 with synthetic division. I'm hoping to get a remainder of 0. So I bring down the 2, I multiply, and I add, and so these numbers are a little big, -13, multiply, positive 39, add and get 32, and then multiply and get -96, add and get -13, multiply and get 39, and sure enough, it went in evenly, right? I got a remainder of 0. And so that means I have now factored the polynomial. So x plus 3 was a factor. And these give me the coefficients of the remaining factor. Oops, so this is 13x squared and then 32x minus 13. Now, if I wanted to, I could start this process all over again. I could graph this and do my P's and Q's, but I don't need to. I sort of already have all the stuff I needed to know. Got my P's and Q's, I have my graph from before. I think 1/2 is the next solution. And so now I go to this cubic. Do not go back to the original function. So I go to this cubic, and I think 1/2 is a solution, so I'm going to put 1/2 out in front and try synthetic division again. So the 2 comes down, multiply, I get 1, add -12, multiply, I get -6. What's that going to give me? 26, multiply, I get 13, and sure enough, I get 0. And so what does that mean? It means if 1/2, that's not a negative there, that's a positive 1/2. If 1/2 is a 0, then x minus 1/2 is a factor. I already had x plus 3 as a factor. And now my next factor is 2x squared minus 12x plus 26. If I wanted to, I could pull a 2 out and try and factor this. The problem is I don't really have much hope of it working because I've already found everything on my graph. And so I'm probably just going to go to the quadratic formula. And so when I go to the quadratic formula, 2, -12, 26, this may be what happens to you, depending on your mode. So it's giving me non-real answers. Okay, but there are some answers. They're just non-real. So if you get that message, you need to go to the mode screen and make sure you've got it set up to deal with complex numbers, a plus bi format, and then try the quadratic formula again. And so 2, -12, and 26. And sure, well, so you probably want to double check your quadratic formula also. It looks like I did not double check this one. It's missing one of the answers, so I'll have to go back in and fix that. The other answer would be 3 plus 2i. And so the 4 zeros end up being -3, positive 1/2, 3 plus 2i, and 3 minus 2i. And so I have 4 zeros, sort of just like I expected, because it was a 4th degree polynomial. So sort of a lengthy process, but especially when you have the calculator to help you, you can move through it and find all those zeros. So we'll be working on that throughout the week.